Alright, let's talk about interpreting categorical data. Now, by the end of the lesson, you should recall how to create a two-way frequency table and a stack column graph. And then you should be able to analyze the table or the column graph and provide a clear and coherent explanation with supporting evidence when discussing association of data. Let's have a quick recap. When we talk about two-way frequency table, we can actually create a row percentages or column percentages. So if we talk about row percentages, the explanatory variable is actually the row, whereas for column percentages, the explanatory variable is the column. We could actually think about drawing this in a graph. So for a column percentages, we can actually create a segmented column graph or a stack column graph. The y-axis is always percentages and the x-axis is always explanatory variable. Alright, so now this graph is actually based on party A and party B from previously, which is this one over here. We could actually, for the row percentages, we could actually draw a stack column graph as well. Just like previously, this is percentages, this is male, and this is female. So you can see that I could do the same thing. And of course, this is 100%. And what we could do is, let's say for party A, 67%. So this is party A, and this is party B. That is 67%, and this is 33%. And for female, party A is 41%, A 41%, and B is 59%. Alright, you could do it this way. This graph was a little bit small for me to write, so therefore I didn't really write the word party. So you should actually always label it properly. Or you could actually use things like hash, which means a legend. Alright, I've got hash, in this case that's male, and straight line as female. Alright, now let's look at an example. What I would like you to do is pause the video for a while and work on part A and part B, which is draw a frequency table showing the row percentages and draw a proportional column graph or stack column graph. Involve 3 columns of equal height with 1 column for each of these 3 age group. So 1 column for each of these 3 age group. So let's think about row percentages. What it means to me is the age in years is the explanatory variable. So if you read the question, it says a number of men were asked which was their most preferred type of movie out of crime, romance, or horror. So we are thinking about the age group. Is there any association of age group with the movie type or film type they like? Alright, let's try and work out the frequency table. Let me review my answer now. Let's have a look at the frequency table. This is what you should actually get. The total for each column should be 100%, and then you should be able to create the stack column graph. So make sure that you label the age group for the x-axis, and percentages is always y-axis. Now, of course, labeling this is pretty clear, or again, like I say, you can use the legend. It is up to you. Let's really think about how we could analyze this. Let's start off with answering the question. Thinking about what we should write. We should compare things like romance, crime, or horror. Also, you need to think about the percentages. Think about whether there's a difference. Think about whether there is no difference. Now, in the exam, if you're given a question like this and 3 months are allocated, you must write 3 points. And then the last point is always there is a suggestion of an association between age and preferred film in this case, or there is no suggestion of any association. Alright, we'll use the word suggest. One of the points must be this. Now let's think about what we could say. So across the 3 age groups, the proportion of males who prefers romance are similar, which is pretty true, 11, 12 and 12%. Now, then let's look at crime. The proportion of males aged between 21 to 35, 25%, who prefer crime is approximately half of those aged between 36 to 40, which is 48%, and 51 to 65, 54%. You could actually use approximately half, or if you want, work out the difference. Alright, which means the difference of percentage between male age group between 31 and 35 and 36 to 50 is 48% minus 25%, which is 23%. Alright, you could talk about the difference as well. And then let's talk about horror. The proportion of males aged between 21 to 35, 64%, who prefer horror, is approximately twice, again I use the word approximately twice, the population of male aged between 51 to 65, which is 34%, and the proportion of male aged between 36 to 50, which is 40%. Alright, so let's think about why it is significantly lower. It is actually the difference 64 minus 34, that is 30%, 64 minus 40, that's 20%. So you can say that because there is a lot of difference, there is a suggested association. Alright, then the last point, the proportions of preferred film type for males aged between 36 to 50 and 51 to 65 are quite similar and are significantly different from males aged between 31 to 35 in the category of crime and horror. And therefore, we can suggest that there's an association between age and preferred film type. I always use the word suggest because we cannot be very definite. Now, second example. I would like you to work through this example. Again, think about what we need to do. Alright? So, we are classifying people as one of these 3 categories: left-handed, right-handed, mixed / ambidextrous. Alright? So, let's think about it. This one, what we need to think about is consider the handfulness of firstborn child. Could it be explained by the handedness of the mother? Alright, this is the table produced. So what do you think we need to talk about? What is the explanatory variable? Alright, so here the word explain. Explained by the handedness of the mother. So the handedness of the mother is the explanatory variable. Alright? So let's pause the video for a while and work out the column percentages. And then let's use it to identify and comment on any pattern shown. And then state if there's any association. Alright. Now, I highlighted the word column percentages again. So if you could do that, please. Alright, let's have a look at my answer. So, generally, for working out the percentages, you just give a whole number, and therefore, occasionally, it may add up to 100%. That is due to rounding. So that could possibly happen. So in the exam, you could explain that if you like. Just compare your answer to mine. And let's look at my explanation. So let's talk about how we could explain the whole situation. Moving across the column, the proportion of handedness of firstborn child for the mixed / ambidextrous handedness of mother is significantly different from the other 2 groups. This time, you need to think about the sample size. Because the sample size is small, the data is actually of limited use. Alright? And then, think about the proportion of left-handed children who have left-handed mother is significantly higher than those who have a right-handed mother, 11%. All right? And then the proportion of right-handed child who have right-handed mother, 84%, is slightly higher. Not significantly, I would say slightly again, higher than those who have left-handed mother. So you can say the difference is 4% and the difference is 6%. All right? In fact, there is not a lot of difference between 4 and 6%. So in this case, we could suggest a weak association, all right, between the handedness of the mother and the firstborn child. So we normally look for something which is above 5%. I will give you a structure. Now, this is actually written by the book, and this previous one is just written by me. So you can compare both ways. Let's now think about the structure of the response. So you always must determine which variable is explanatory variable and which variable is a response variable. Then you actually need to work out the column or row percentages. Then, if needs be, draw the stacked column graph. Then discuss. So this calculation and drawing the graph, and 2 is explanation. Discuss whether there's a change in percentages as you move across the explanatory variable. It is important that you use numbers. Numbers because you need to give mathematical reasoning. All right? Always the percentages to back up your argument. And pick the explanatory variable with the biggest difference, at least 5%. And then determine whether there's an association between the two variables or not. And do not be definitive. You can only suggest that there's association between the two variables. All right, I'm going to stop the lesson here. So just recap of what I've talked about. I will discuss a lot more the next lesson. Thank you.